Hello, grade 10. In today's lesson, we're going to be looking at pulses and waves, and we are tackling exam type questions. Now, let's see the question that we have here. We have question 6. It says, study the two transverse waves, P and Q, as shown below. Now, we have wave P, which is in bold, and then wave Q, the one that is dashed. Now, we can see the information that we are given here. Our position is in millimeters, and then we are also given the distance between 2 points here. Let's look at these points. What are these points? We can see that these points that are in phase. What do we mean by points that are in phase? Now, if you can look at the particle direction after B, it's upward. The particles will be moving upward after B. And what about after D? Also, the particles, they'll be moving upward. Now, if 2 points are having the same particle direction, we say they are in phase. Now, if 2 consecutive points are in phase, we say they complete a full wave, one full cycle. Now, that means the distance between them, the distance between 2 consecutive points that are in phase is the wavelength. So that is the definition of the wavelength. If you can go back to the definition of wavelength, it says this is 2 consecutive points that are in phase, which is B and D. That means, in other words, the 100 millimeter that we've been given here is your wavelength. Now, in that way, we have analyzed our question. Now we can just write in our data wavelength is 100 millimeter, right? But now you will remember one thing. Our wavelength should always be given in meters. Now we need to convert our millimeters into meters, right? Now, how do we convert millimeters to meters? Now you will know that we always have to divide by 1,000. Now, if you can take the 100 divided by 1,000, now we have our lambda wavelength is 0.1 meter. Now you leave it like that. We are just only analyzing the question. We are writing out our data. Now let's move forward. Let's move along with the question. It says 6.1. Write down one difference and one similarity between wave P and wave Q. Now, what is one difference that we see here? If you can check here, the displacement from rest position to the maximum height is not the same. Now, we can see that in wave P, the maximum displacement from rest position is 15 millimeters. So it goes all the way to that height. So that's 50. But what about wave Q? The maximum displacement from rest position is only 10 millimeter. Now, what is that? We define it as what? The amplitude. So remember, amplitude is the maximum displacement from rest position. So we can say what is different here is the amplitudes of the two graphs or the two waves. And then what is one similarity that we see here? What is that one similarity that we see? Now, if you can check here, from this point all the way up to this point, we have a full complete wave, right? Now, how many seconds does it take to complete this wave? That's 1.5. Now, we can all see that it is true for both the waves. For wave P, it takes 1.5 to complete a full cycle, and also for wave Q, it takes 1.5 seconds to complete a full cycle. Now, what is the time? What is the time taken, or how do we define the time taken to complete a full wave? We call it the what? The period. So we can say what is similar here. One similarity that we have is the period. Also, again, another similarity that we have, if you can check at this point to this point, that's the wavelength, which is also the same length from this point to that point in wave Q. So we can see the period is the same and also the wavelength is the same. And also the wavelength is the same. So they only needed one. Now moving along with the question, it says 6.2, for wave pattern P, so we're only focusing on wave pattern P, write down, so no calculations needed here. So write down 2 points that are out of phase. Now what do we understand by points that are out of phase? We say points are out of phase if the particle direction is not the same. Now if we can check at point A, in point A, after point A the particles are moving downward, but after point B the particles will be moving upward. Now we can see between A and B the phase or the particles are not in the same direction. That means the points are out of phase. Also for B and C, for B the particles are moving upward, but after C the particles are moving downward. So they're out of phase. Also B and C is out of phase. Now moving along to 6.2.2, it says the amplitude of the wave. What is the amplitude of the wave for wave pattern P? Now the amplitude, we've already spoken about it. It's what? 15 millimeter. Remember, this is the distance, the maximum displacement from rest position, from this 0 position here all the way to the maximum height. So we have 15 millimeter. Remember, it did not state that you should write it in meters, but then be careful if the question wants that. Then 6.3, define the term frequency of the wave in words. What is frequency? Let's define it. So we say we define frequency as, we say frequency is the number, of waves passing a point per second. Right. So this is the number of waves passing a point. So this is point per second. Now 6.4, it says for wave pattern Q. So now we are focusing on wave pattern Q. Calculate the frequency of the wave. Now you will understand that we have two formulas to calculate the wave or the frequency of the wave. So we have F is equals to 1 over period, and also V is equals to F times lambda. Now both these formulas can be used to calculate frequency. Now if we have two formulas which we can choose from, it's only a matter of collecting the right information or data in order that we choose the correct formula to use. Now let's say we were to use this one. Now we're looking for frequency. Do we have the speed? Do we have the speed anywhere here? We do not have the speed. But do we have the wavelength? Yes, the wavelength we do have. That's your 100 millimeter, which we converted in the beginning of the question, and we got 0.1 meter because it should always be given in meters. Now you can see that with this one, there is a problem of the speed, right? We do not have the speed. Hence, in order to use this one, we would have to first get the speed, and then we can calculate the frequency. But if we check the marks that we are allocated for this question, it does not allow us to first calculate a missing quantity and then come to frequency. Remember, 3 marks only means that you have to choose the correct formula, substitute into that formula and get the correct answer. So that means we have to go to this one. Let's choose this formula. Now, if we choose this one, we can see this is F is equals to 1 over T. Now, the T here is for what? This capital letter T, we define it as the period, which is the time it takes to complete one full cycle or one full wave, right? So now we have already got that from the question, right? Now, remember here, when we analyzed, we said the period here, when we analyzed, we said the period was 1.5 because from here all the way to this point, this is a complete wave. So it takes 1.5 seconds to complete a wave. Now we're going to use this formula, F is equals to 1 over T. Substitute here, we're going to have 1 over 1.5, right? So if you put that in your calculator, you get your frequency. Now, you punch that, it's 0. That's 0.67 hertz. Now, do not forget to put in your SI units. Very, very important. Then 6.4.2, it says, now calculate the speed of the wave. The speed of the wave. Now, can you see we are now looking for the speed? Now, for the speed, we have this formula. F is equals to F times lambda. Now, we have already calculated the frequency in the previous question. So, we have 0.67. And then what is our lambda? We cannot put the 100 millimeters because we want it in meters. So, we converted that 100 millimeter into 0.1 meter, then you multiply. What is 0.67 times 0.1? We have 0.067 meters per second, and that's how you calculate the speed here. So that's it with this question, guys. Please come back to this video, refer to the question just at your own pace.